Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a problem number 4. Now in this numerical we are going to study ROCs, or you can say that we are going to find out the inverse Z transform using help of ROCs. Now first of all, there are three types of ROC. First one is causal, another one is anti-causal, and last one is two-sided. So let's go through the numerical problem number 4 first. Problem number 4. A discrete time system which is known to be stable and having a function. Now here it is mentioned it is known to be stable, means what? We are not going to find out any stability, or we are not going to check the stability of given function. We'll only see the inverse Z transform. And having a system function h of z, in numerator we have 1 minus 0.2 Z inverse, and denominator we have 1 plus 0.2 Z inverse and 1 minus 2 Z inverse. Now what we are going to do? We are going to find out x of n using inverse Z transform, but for all possible ROCs. So which means we have to find out inverse of this function but for all possible ROCs. So first of all we'll find out inverse Z transform by using partial fraction, and then we'll move on to ROC. Now the function h of z is given and it is in question. Now what we are going to do? We have to find out h of n, but for that we will use a partial fraction technique. Now we already have two poles, which means we will use two variables or polynomials. And let's say this is nothing but my equation number 1. Now next step is always just multiply the left hand side denominator on the right hand side. Now what you will get? If I multiply this left hand side denominator on right hand side, then we can say that 1 plus 0.2 Z inverse, 1 plus 0.2 Z inverse will get cancelled. Only A will be multiplied with 1 minus 2 Z inverse. And similarly next one with B, what you can say? Just exclude 1 minus 2 Z inverse. Only multiply 1 plus 0.2 Z inverse with the B. Now this will be my equation number 2. What we are going to do? We have to calculate the values of A and B, but for that we need to substitute Z inverse value. Now let's see, if we want to remove A, then what we are going to do? We have to obtain 2Z inverse value is equals to 1. Now for that, if I substitute Z inverse equals to 0.5, then 0.5 into 2, which gives us value 1, and 1 minus 1 will get cancelled, or you can say the result will be 0, and 0 into A is 0. So you will get the value of only B. So I'm going to substitute Z inverse equal to 0.5. So we can say that a 0.5 or half. Now what is the next step? Just substitute this value in whole equation. Now look at here, these 2 and these 2 will get cancelled, so we have 1, and 1 minus 1 is 0, so your A will be removed from this equation. Now look at here, 0.2 divided by 2, what will be the answer? The 0.2 divided by 2 is 0.1, and 1 plus 0.1 is, answer is 0.1b, or you can say 1.1b. and similarly these two also, these 2 and 2 will get cancelled, so we have 0.1 over here, and 1 minus 0.1 is 0.9. Now what is the next step? Just shift this 1.1 on left hand side. If I shift the decimal dot on right hand side, then you will get, and this is nothing but the value of B. Similarly we will calculate the value for A also. we have already calculated the value of b. Now we want value of a, so which means we have to remove this b value. Now how to remove this b value? Here we have a plus sign, which means we have to substitute z inverse value, which is having a minus sign, as well as we have to substitute the value of z inverse such that it is having a minus sign, as well as this will remove the 0.2 value. If I substitute 1 upon 0.2, then also it is fine, because 0.2 will get cancelled. But if we substitute z inverse equals to 5, then also it is fine. So I'm going to substitute z equals to minus 5, or else z inverse equal to minus 1 by 0.2. Now we are going to substitute z equals to minus 5, and this is our equation number 2. Here we are going to substitute the minus 5 value. So all the z inverse will be replaced by a minus 5. Now look at here, 0.2 minus 5, answer is minus 1, but here we already have minus sign, so minus and minus becomes plus 1, and this will give us answer 2. Now here also look at here, 5 2s are 10, but we have minus 10 result, but already we have minus sign outside, so minus minus become plus, so 10 plus 11, answer is 11a. Now look at it, minus 5 into 0.2. If I shift this minus 5 or minus sign outside, then this plus sign will be replaced by minus sign, and 0.2 into 5, answer is 1, and 1 minus 1 is 0, so b value will get vanish. So only we have 2 by equal to 11a. Now if I shift this 11 on left hand side, then we will get the value of a, that is 2 by 11, and this is our result of a. Now simply substitute the value of a and b in equation number 1. Now we are going to substitute the values of a and b in equation number 1. Now what is the next step? Basically we want one z in numerator before moving to inverse z transform. So my suggestion is simply multiply numerator and denominator by z, so that you will get z in numerator in both the cases, as well as this denominator will also changes to z plus 0.2 and z minus 2. Now we have studied one formula before moving to inverse z transform. We have studied one formula, that is a raised to n u of n. The a raised to n u of n is z upon z minus a. So here my a value is 2, but look at here we have z upon z plus 0.2, which means here the value of a is a minus. So now I'll apply inverse z transform, and then you can see the changes. Now here the a value is negative, that's why we have got z plus 0.2. So my value of a is minus 0.2 raised to n, and if I remove this value, then we will have z upon z minus 1, and unit, it is nothing but z inverse transform of unit step. Now here my a value is 2, so I'm going to write 2 raised to n, and z upon z minus 1 is u of n. Basically we can directly obtain this inverse z transform of this equation, or else basically in this question mention that the inverse z transform that we have to obtain, but by using ROCs. Now we have already calculated this inverse z transform. Now we'll do some changes by according to ROCs, because for a causal this unit step is represented by unit step only, but for anti-causal or non-causal this unit step is replaced by minus u of minus n minus 1, and maybe this will produce a two-sided function also. So let's see the first of all ROCs, and then we'll do the changes in h of n. Now this was our h of z. Look at here, the first pole is at z plus 0.2 and another one is at z minus 2. So we have to find out the pole location. So just simply equate the z plus 0.2 equal to 0. Similarly, z minus 2 equal to 0. So what we will get? We will get two poles. The first pole is at minus 2, 0.2, and another pole is at plus 2. So according to this, we can plot the pole 0 plot. On y-axis I have written imaginary part of z, and on x-axis we have written real part of z. Now here in z transform we will always plot the pole value by using help of a circle. So here we have a minus 0.2. So basically our mod, here we always take a mod z value. So we will plot a 0.2 radius a circle, or you can say a circle of 0.2 radius. So let's say this is the one pole. Now second pole is at 2. Now from this what we can say, you will get three types of ROCs. As I told you earlier, if we have a two pole, then of course we will have a more than two ROCs, or you can say a 2 plus 1 ROCs, which means if we have a n numbers of poles, then we will always have a n plus 1 ROCs. Now look at here, the first ROC, what you can say, the first ROC is causal, second will be a non-causal or anti-causal, and third one is two-sided. So for first of all, a causal ROC, how to write the equation or ROC value for causal ROC? If mod z is greater than a rightmost pole, that is 2, then this will gives us a causal ROC. Now what about non-causal or anti-causal? If the leftmost pole, that is a 0.2. If the ROC is less than leftmost pole, then this will produce a non-causal or anti-causal ROC. And the last one, that is two-sided. If the ROCs exist between 0.2 to 2, that is, if our mod z is lying in between 0.2 to 2, then this will gives us a, you can say, a two-sided ROC. Now we will write the equation for, or you can say that inverse z transform of h of z will find out using these three ROCs. So first of all we'll calculate ROC for the mod z is greater than 2, and then later on next 2. Now we'll find out inverse z transform, but for first ROC. Here the first ROC is mod z is greater than 2. Now first of all we will plot two pole values, or you can say two circles of radius. First one is 0.2, another one is 2. The first ROC is mod z is greater than 2, which means our ROC is exist where the exterior part of two circle. You can say that here a mod z is greater than 2, which means a causal ROC, and this causal ROC is exist where outside the circle, where which is having a radius 2, which means our ROC is available in the exterior part of a circle having a radius 2, which means here the ROC is available. Now we'll find out, or you can say we will apply inverse z transform to get this ROC. On which equation we are going to apply inverse Z transform? On this h of z. So this h of z is replaced by h of n. Now look at here, we already have a 1 by 11 and 1 by 11 on both the sides of this part. So I'll take 1 by 11 common. Now next part. So here we have only 2, and now z upon z plus 0.2. As I told you, here we have plus 0.2, which means we have to take a value as a minus 0.2 raised to n. Now as the function is causal, which means we will write, or we are going to write u of n in both this part. Now here the constant is 9, so I have written first. Now what we have, z upon z minus 2. Now here the value of a is 2, so I'll write only a 2 inverse, and the rest of the part is z upon z minus 1, which is nothing but the unit step response, or you can say inverse transform of unit step. Now similarly we'll find out the second ROC value. Now here the ROC, the mod z is less than 0.2. So first of all we'll write, or we'll draw the two circles having radius 0.2 and 2. So inner circle is having radius 0.2 and the outer one is having radius 2. Now what is mentioned, a mod z is less than 0.2, which means our ROC is exist in the interior part of 0.2 circle, or a circle having radius of 0.2. So where we are going to plot the ROC? Inside this 0.2 radius circle. Now we'll apply inverse Z transform on this equation. So h of z is written as h of n. Again here 1 by 11, 1 by 11 is constant, so I'll write 1 by 11 outside. Now this 2 is a constant, so I'll write first. Next part, the value of 0.2. This is the location of a. Here the sign is plus, so we will write a minus 0.2 raised to n. Now here the ROC is anti-causal or non-causal, which means we are not going to write u of n. We will write minus u of minus n minus 1. Similarly here also, here we have a constant value which is 9. Next the a value is 2, so I'll write 2 to the power n. Now here we have z upon z minus 2. Now two values already written. Now next part is z upon z minus 1. But we are not going to write here u of n. As this ROC is non-causal or anti-causal, we will always write minus u of minus n minus 1. So this is the response or inverse of this function when the ROC is non-causal or anti-causal. Now we will calculate the ROC for next one, that is a two-sided. Now the third one, here the ROC is lying in between 0.2 to 2, which means our ROC is exist in between 0.2 radius circle and 2 radius circle. So first of all we'll plot the circle. So these are the two circles. The first inner circle is having radius 0.2, another last one is having a circle radius 2. Now according to ROC, what is mentioned, the Z or mod Z, that is ROC, is exist between 0.2 to 2 circle, which means our ROC is exist in between 0.2 to 2. So in between these two circles our ROC is exist. So we'll draw a parallel lines, but in between 0.2 to 2 radius circle. So this is the ROC of two-sided function. Now what we can say, that the radius of 0.2 circle produces a causal ROC, whereas a radius to a circle produces anti-causal ROC, which means this, in this case, whenever we are going to write u of n, this ROC or this pole produces a non-causal ROC, so we are not going to write u of n. This will, u of n will be replaced by minus u of minus n minus 1. As this point 2 produces a causal ROC, which means here we are going to write u of n only. So now apply inverse Z transform. Now again here also I have taken 1 by 11 common. Now the 2 is constant, so I'll write first. Here this is the position of A, but here the sign is plus, that's why we'll write a minus of 0.2 inverse. If here the sign is minus, then I can directly write 0.2 only. Now this 0.2 is producing causal ROC, so here we'll write Z upon Z minus 1 is replaced by u of n. Now the next part, here the 1 by 11 already have taken common, so we have only 9 as a constant. Now here we already have the equation Z upon Z minus 2. So if I compare with Z upon Z minus A, it is nothing but A raised to n into u of n, but this radius to circle produces a non-causal ROC, so we will replace u of n by minus u of minus n minus 1. So this is all about ROCs and the inverse transform. So according to ROCs, the h of n value changes. What are the changes you can see? Now here you can see the changes in h of n, and these changes is basically because of ROCs. If the ROC is causal, then we will always place a u of n. If ROC produces a non-causal, then u of n is replaced by minus u of minus n minus 1. So this is all about the ROC. We will study a similar numerical in next video. For that, stay tuned with Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.